Hi everyone, welcome to the Hamoye August webinar series. My name is Mohamed Azarazi. I'm the lead data scientist at Hamoye Labs. So today we'll be talking about a very interesting topic. And the topic is completing a machine learning project. Today I'm joining in from Abuja, Nigeria, and I'll be your host. So like they say, the best way to learn machine learning is by designing and completing projects. So before I proceed, I would like to invite one of the AI team member, Orica Precious, share one or two with us. So Precious, are you here?
Yes, I'm here. Good evening, everybody.
Okay. Good evening. Sorry. So you were part of the Hagues the last year, 2020, and you completed like 3 projects: fraud
Yes,
detection, USA, presidential election. Then you also had the final one, UK road safety. So can you share with us like your experience, like how was the experience like generally?
Generally it was very taxing. Like while I was an intern then, it was very taxing, and I know how many sleepless nights I had, right? The thing about open source project is you get to collaborate with lots of people from diverse places and different time zones. Like I had a colleague from India and another from Uganda. And so you can imagine the time frame where I have to set up a meeting and we had to have those projects on. So it was very demanding. I'll just chip in some little things. I would like to say there are some points where you feel like that you're doing it alone. You feel your teammates are not collaborating, which is very, very similar in any place you're working. You always feel that you're the one doing it alone. So I would advise before you start up those projects to not get discouraged. I think it's something that will help you along the way. Like now I'm working with Hamoye and I do these real world projects, real life projects. And it's amazing because those experience I had earlier as an intern has really helped me going forward. Talking about the project I did, I think the one that interested me most was the US presidential election and road safety, and also the fraud detection. The fraud detection was interesting because we had to develop an app with it, and we actually tested it. So it was really amazing. Then for the US presidential election, we're very lucky to accurately predict the winner of the presidential election, which is something awesome. And Hamoye published it as well. You can check the Hamoye blog on that as well. So it's something that going forward, you discover that you have so many you have so many workload, and it gives you this edge to be able to balance your work, Hamoye, and other personal things, because it's a remote internship, as you can see. So it's something that's going to be very, very beneficial, but it's very taxing. You're going to be, just to chip in some little details, you're going to encounter some, what's it called? I think group tax and leaderboards and the rest of them. So I think the motivation here is that you see how you progress from the infant level to where you are in now. So it was really, really amazing so far in the Hamoye internship. And now working on real life projects, it's another ball game entirely. You know, internship is different, right? You are like somehow tutored and you're held by the hand to do some projects. But now you're doing them without probably no much effort, although you have your colleagues to work with. And I was fortunate to work with some of these colleagues I did with in my internship. So it's been really amazing. So yeah, it's really, really fun so far.
Okay, so thank you very much, Precious. So like you all know, at Hamoye, we not just teach you how to do things, we also allow you to, try these things out in real life projects. So how would you like what was the most tasking part, like out of all these 3? I know one of it must have given you like a lot of headache, maybe trying to get data, or maybe the data was so bad, like the processing and all that. So which of them would you say?
I would have said I would go with US presidential election because of the data we had to combine. We had to get source for data from different, we had to source for Senate, we had to source for districts, you have to sort for the presidential level and counties as well. But I think the fraud detection was the most taxing because it was a different domain from the background I had coming from a chemical engineering background. So it's very, very taxing because we're working with how customers react and how this credit card functions. And it's more of like a business or economic side of it. So it was really, really taxing, working with different colleagues, and everybody was trying to bring in their models to work with, bringing in classification, different types of classification models, bringing in different tools and stuff just to make sure it works. So it was the most taxing of all, which is the fraud detection, but it was worth it.
Okay, thank you very much, Precious. So the first person to join this meeting today is Dorothy. I don't know if she's still on this call. Can you raise your hand if you're on this call, Dorothy? Okay, so I don't know. I don't think she's still on the call. So we have somebody that is raising their hand on Zoom here. So let me allow you. Okay, so you can speak now, Jude. Easy.
I was just having difficulty in listening initially, so I wanted to ask what's going on with the network. So, but I already rectified the issue already.
Okay, so thank you very much.
You're welcome.
All right. So if you have questions during the course of the presentation, you can drop them on chat boxes on Zoom or on YouTube, and they'll be attended to. And you can also raise your hand like you saw Jude did. You can raise your hand and you're permitted to speak. So today we have our resource person, Biodun Awojobi. Like you all know, he's a customer engineer at Google Cloud Platform. He's not just that, he is also a professor of cybersecurity in the University of Dallas. He has over 15 years experience in this field. So trust me when I say he's going to do justice to this topic. So while we wait for him to join us, I would like us to do a little bit of so you can drop your comments on the chat box. So which part of the machine learning project do you think is most tasking? So you can drop your comments here. Okay, so we have our resource person here. So I would like to welcome making models. Wow. So Victor here is saying making models, deep learning. Okay, so we have our resource person here with us now. So I would like us to welcome Biodun Awojobi. Thank you, Biodun, for joining us today. You're on mute, Biodun. Okay. Okay.
Hello, can you hear me?
Yes, we can hear you now.
All right, just a second. All I need to do is I would love for the audience to see my face. My apologies for running late. I'm at the airport at the moment, and I just thought to myself, as against waiting till I get to my hotel, I may as well just dial in now and have the chat. I have a deck that I prepared for the audience, and I'm ready to go. Just give me a second here, and I'll present my screen. You may get another request from me to join the meeting because I'm joining with my computer. Okay. When you hear sounds in the background, I'm apologizing in advance. Like I said, I'm at the airport, so.
I understand. Thank you very much for joining, regardless of you.
Yeah, so absolutely. I get it. I'm getting an alert that the meeting is at capacity. So I'm going to drop off this and hope that you can add me back in.
Yes, I will do that.
Okay.
Okay, so we have some comments here on Zoom. Yes, sir. Okay. So Chico Abdul Salam, if I'm correct, is saying, is there a particular, sorry, EDA? So that's the exploratory data analysis. And then we have another person here saying sourcing for data, that's Kennedy. Okay. So okay, so we have another question from Olex, and the person is asking, my major problem is how do I learn all the things within a short time? I'm a beginner and I'm being really tasking to know all these things in data science. Any advice for me? So we'll answer all these questions once our resource person gets on the call. So just give him a second.
All right, very good. Can you hear me now?
Yes, I can.
Fantastic. I realize that there's a lot of people on the call. And again, my apologies for keeping you all waiting. There were situations extremely out of my control that led to this happening. So I apologize. I'll keep the presentation very short. There were way more things that I hope you can all hear me still.
Yes, we can.
Okay,
Yes, we can.
yeah. There are way more things that I wanted to cover initially. Well, hopefully you will get the gist of the message. I'm not taking data science at a very deep level for this conversation. I'm going and giving an overview, and hopefully you can get some pointers that you might be able to take advantage of. Right, I will share my screen. Do I have access to share my screen?
Let me just confirm that.
Yes, you do know, Builder. You do know.
Okay, so you can share a screen now.
All right, sure. I will do that just now. And just to make sure that the internet doesn't mess up, especially since I'm at the airport, I may not use my camera for now, but at some point I'll turn it on once the presentation is over. Let me share my screen. All right, put this in presentation mode. So every now and then you may hear like sounds come from the background. Again, it's because I'm at the airport. So you can feel free to mute or reduce your volume. All right, so the topic that I've been asked to present today is completing a machine learning project. And I will start out by giving an introduction to myself. I would also kind of do a bit of an AI ML trivia for the audience. And then we'll just kind of start out with what is AI ML, just from, and I hope that the AI ML trivia will kind of provide a little bit of clarity on that. This might not be new to a lot of you. This might not be new to a lot of you, but I would say for a fact that there are some concepts that I would be running through in this session that hopefully you would learn new things from. The next thing on the agenda will be what a typical machine learning workflow looks like, and I'll have some closing remarks. There's a slide that I put in there that just kind of opens you guys up to some of what we're doing at Google with Vertex AI. If you all haven't heard about it, I'll highly encourage that you go take a look at it. So 30 minutes kind of starts now, and I'll leave about 7 minutes for questions. All right, so who is Bio? Oh, I go by Bio here, by the way. I go by Bio in the US. I'm based here in Dallas, Texas. I'm not in Dallas at the moment, but I'm based in Dallas, Texas. I was born and raised in Lagos, actually. So I moved to the US in 2011. And what that means is I've been in the US now for a little over 10 years. I actually went to university at Lagos State University. I'm thankful and feel lucky, blessed for what the journey has been so far. But overall, I hope this serves as it serves more as an encouragement to all of you that whatever it is that you want to make happen can be possible. I mean, here I speak Yoruba, as you would imagine from my first name, and yeah, because I moved to the US when I was in like my in my mid 20s. That makes sense. So currently, I'm a customer engineering manager. I lead a team of customer engineers at Google. The team that I lead are specialists in different areas of Google Cloud platforms. So some of the folks that report to me are AI ML specialists, like artificial intelligence, machine learning specialists at Google. Some of the folks are data management specialists. Some of the team members as well are data analytics. We have folks that have security experience, infrastructure experience, app mod experience. Just think about these folks as the best of the best when it comes to the areas that I listed. I've been at Google for 16 months. Prior to joining Google, I was at Microsoft for a little over 6 years. I'm also an adjunct professor at the University of Dallas. And just recently, I was approached by University of North Texas to teach data science. So it's one of the reasons why this came very timely. So I could use this as one of the pitches to the folks at UNT. So I'll be teaching data science courses at UNT starting this fall. In terms of what I enjoy doing, I enjoy reading, traveling, just like I'm doing right now, and I enjoy writing too. There are other fun hobbies of mine, but these are just kind of the three that I decided to share. All right. So, like I said, we're going to start out with a trivia, an AI ML trivia. We're going to ask the question first. And the first question is, and if anybody knows on the call, just say true or false. We'll kind of keep this very, very smooth so we can move on really quickly and go through the remainder of the slides. AI is a subset of ML. Is this true or false?
Hello?
Yes. Is it true or false?
It's false.
That's the correct answer. AI ML is not a subset of AI is not a subset of ML. In fact, I could say ML is a subset of AI.
Yeah. Thank
Correct. All right. The next question, actually, I give that away. The next question, artificial intelligence was founded as an academic discipline in what year? Okay, I hear someone doing Google searches. Okay, I'll just give it away. It's 1956, but we won't talk so much about that for right now. The answer is 1956. The third question, Dash is the field of study that gives computers the ability to learn without being explicitly programmed. There should be a question mark over there, but what is that?
AI.
Machine learning.
AI.
Yeah.
Machine learning. Machine learning.
AI.
Machine learning.
All right.
AI.
Okay, we have a lot of people say, I wish, so the plan was that I was,
Machine learning.
yeah, the plan was, the plan was that I was going to join early and we can make this an actual trivia where people do their polls and we can identify who truly won or the group that won. But let's read the question again. What is the field of study that gives computer the ability to learn without being explicitly programmed? I will pick ML, but some people will argue it's one of those controversial questions. All right, I'm gonna try to reduce this. So shopping recommendations on Amazon and Google Shopping is an example of what? Is it AI or ML?
AI.
Getting shopping recommendations on Amazon and Google Shopping is an example of what? Actually, it is an example of ML. You can identify shopping patterns of different shoppers and use their shopping patterns to build models and say, hey, this is what people who buy socks typically buy, and that might be a shoe. So I'll put that in the category of ML. All right. Next step. And sorry about the noise. I actually mute myself right now. All right, I'm back. So what is AI and ML? I define AI ML just from one of the thought leaders from an AI ML perspective defines AI ML as is the field of study that gives the computer the ability to learn without being explicitly programmed. Artificial intelligence, though, is the science and engineering of making intelligent machines. So let's talk about ML in a little bit. The picture that you see here is one of which it's similar to what you would. I don't know if anyone has done a project like this before, but this would be using like a vision API to identify fruits or to even identify objects. So you have to train the model to know that, hey, the one in red over here is a banana. The ones over here are oranges. You have to train the model so well such that it can understand. The same goes for the monitor that you're seeing over here and the domestic cat. That is ML. The more data it has, the better the model looks like. The more you train the model, the higher the accuracy and the predictability of that model will look like. But for AI, I would say that robotics would be an example of AI, knowing exactly what to do based on all the multiple data points that you fed it, such that it understands what's next. And the same goes for your Amazon Alexas and your Google Homes of this world. That is exactly what they do. Those type of devices, they are AI tools. They are connected to the internet. They are doing learning in real time. They're understanding how you're doing things, and they can predict what your next move will be. So if you say for example, a Nest Learning thermostat, if you guys have ever read about that before, a Nest Learning thermostat will identify that, hey, there's someone at the house, and for the past 17 days, the temperature has always been XX centigrade or XX Fahrenheit. And what that typically means is it knows that 3 months from now, what's the probability that the user or the person who lives at the house will want to be at XX Fahrenheit, and it could proactively set those type of temperatures at the house. All right, so I'm going to move on to the next step and talk a little bit about what a typical AI ML workflow would look like. AI ML workflows are it's a common structure, common workflow that we all kind of gotten used to. There are variations in some cases, but what I'm pitching to you here is just a picture that I pulled from the internet of what the 5 key steps in an AI ML workflow would look like. The first step would be to get the data. The second step would be to clean the data, prepare the data, analyze the data, in some cases manipulate the data. The next step will be, and I'll kind of go a little deeper in the next couple of slides. And the next step after that will be to apply and train that model. There are multiple models that exist there are multiple models that exist that you could use. Sometimes if you're working, depending on the type of data sets that you're working with, specific models would apply. So say, for example, if you're working with a picture, maybe you might want to think about using some type of vision APIs or some vision-oriented cognitive type models to help you analyze those pictures. And then same will go for the type of data sets. You can do some form of regression to just create the model and predict what's next. The next step will then be to test the data. We've done a model. We want to know how accurate it is. You can test the model by trying to make some predictions. I remember one of my first few AI projects, which was predicting what type of fruits I was going to be using. I was using a bunch of fruits, bananas, oranges, and I had like a million rows of pictures of bananas and several thousand rows of pictures of oranges. And the more I kept feeding different pictures from paper, pictures from live bananas, the more I kept feeding those pictures, the better the accuracy of that model was. And eventually I skinned an app, and then I used the app to identify. I just go to the shop, take a picture and see how that applies to my model. As data scientists, you probably don't want to go that far yet, but there will be ways where you could test your model and see its accuracy. The next step after that will be then to improve on the model. Improving on the model, there are multiple ways that you can improve on the model. I would say one of the fastest, surest way to improve the model is to always add more data. That's if there are no underlying issues with the model. But we'll go deeper in the next couple of slides as to what all of this means. So let's do a bit of a deep dive into the workflows that I've listed and just kind of talk a little bit more about them. Let me check the time. I think we're still doing well. All right. So getting the data, this is meant to say one. So from a get the data perspective, there are multiple ways to get data. I would like to suggest first that this is an area where things could be a little bit tricky. It's always good to do a bit of self-reflection and understand your why. Why am I actually doing this project? Am I doing this project because this is the first data that I found? Or am I trying to solve a problem? There is no need to rush in terms of finding data. Data sources are available literally everywhere. And the more you spend time and analyzing the data, looking at how complete the data is, thinking through the data, reflecting on what could you make out of this data set now that you have one or two or three of them is pretty important. Because if you just find one data and just run with it, you may realize that maybe there are some things you're not thinking about. So just like I put in here, data is everywhere. There's so many interesting problems that you can solve. I was on the call while one of the participants in the call was talking about the prediction of the U.S. presidential election, who the winner will be. I think the person was accurate about who the winner will be, right? But you do all of that based on data, right? You want to reflect on your interests as well. If you have a why around health, if you have a why around financial data or around finance, or if you have a why around social type issues, you probably are better off looking for data in that space. The good news is data is everywhere, and there's abundance of data out there for you to make inferences. This also begs the question, if you don't know much about a field, doing some type of data analysis on that field might be a little bit more difficult. So I listed a couple of data sources over here, and some of them you may already know about, some you may not. From a cloud perspective, there are data sets available in the Google Public Data Explorer. Enterprise data warehouse solutions like BigQuery also has easy access to ingest data. Actually, that would be the next path that I would challenge you all to start looking at. How can you do all of the analysis that you do today with your Jupyter Notebook? How can you do it all in the cloud and do all of your Jupyter Notebook work in the cloud and access the data directly and build out your pipeline? What would it take for you to start doing that? That is the next level, because cloud is the future. There are also data sets in the cloud around the Freebase or Amazon data sets are also available as well, just depending on the platform that you're most familiar with or the one that you want to go learn more about. Now, you also have government data. I mean, if you want to learn about, hey, how does the highway in London, how does it work? What are some challenges that you're seeing? What are some predictions that you can make? London Data Store has some good rich data set that you might be able to take advantage of and make some sense out of it. But all of this requires reading. The field of data science requires you continually reading, because if you don't read, you may not understand the social issues or the financial issues or the various impacts that a lot of folks are not taking advantage, that they're not thinking about. You may not get to understand what they are. Kaggle, I bet almost literally everyone on this call probably knows what Kaggle is. You can get lots of data, competition type data on Kaggle. The other data sets that are available, and I put a link in the deck with like a comprehensive list of data sets. You have Financial Data Finder. You also have like Cancer program set. Cancer program data set. I know that some folks on the in one of the cohorts that passed for Hamoye worked on some of those cancer data in the past. The next step, just to kind of do a double click into the next stage, is the import, clean, analyze, and manipulate the data. There are multiple ways you could do that. A lot of what I do today just kind of all revolves with using cloud tools, because they make life so easy. Obviously, it comes at a cost in most cases, but they make life extremely easy. There are a couple of considerations, because I think cleaning data is probably the most important step outside of finding the data set that you want to use and making sure that you have a true passion to investigate the data, cleaning the data, making sure that the data is right, the data is well transformed, the data doesn't have missing rows, and if it does have missing rows, you have a plan to address those, and you're able to actually realize your true vision of the project. Cleaning data is probably, in my opinion, one of the most important components of an ML project. A couple of thoughts that I put and considerations that I put on the right hand side, just like having a plan for your missing values. If you have missing values and you realize that, hey, I really need this row, your plan may be to do some type of randomization, your plan may be to do some type of bootstrapping. You could have a plan, but make sure that plan, you know what the resulting effect of that plan that you're taking on those type of issues with your data. Also ensuring that the data is converted. There are times where you pick data sets that are in different languages or different units, or haven't been normalized because the IoT device that it came from or the machine that it came from were just not proper, and it needs to be randomized, or it needs to be normalized. Making sure that that's normalized is critical to the success of your eventual project, because if it's not normalized, you may be getting some improper data, or your model may not even run at all. Another part that I think, in my opinion, is very important
at this stage and even at the very end of your ML project is visualization. It's making sure you have visualization tools that you could take more, you can zoom out and look at the data and just do some type of spot checks as to what is wrong with this data, what are like some potential issues that I can get. Visualization is an art. It's something that needs a lot of practice, and so is data science in its all in itself. But I recommend that you visualize the data, especially the rows that you're going to be working with. Understand what the trends are with the data without even applying any model yet. That could give an indication of what is to come, or at least let you know if there are some things that you could spot check about the data. As you all know, the data science field, a lot of organizations are looking for folks that are looking for expertise in Python, expertise in R, especially in Python. There are times where a spreadsheet might be enough for you to do your to clean up your data, but there are times where you would have to use Colab, you have to use Python to clean up your data and make sure your data is useful. So just some considerations to think about. From the applying and train the model perspective, there are multiple tools that are available out there. Like I am I use more of the tools that are in the cloud lately, and some of these tools exist in the cloud as well, where you can kind of have like different types of models, like the regression model, and all of these models apply to different. And this is not an exhaustive list, by the way. All of these models apply to different types of data sets. Like a dimension reduction model, I remember using that in my PhD dissertation. It really helped me identify what the patterns are with my data set, but I couldn't use it for other types of data sets. Say, for example, a picture. If I have a picture data set, it might not be the right type of model that would apply. So the other type of modeling that you could do would be clustering and deep learning. But this is a deeper conversation, so I may have to table this for another conversation. I'll just put links in the deck and I'll share that with the team. So once you've done the applying the model to your data sets, once it's been cleaned and it's been trained, the next step really is to test the model and make predictions. Say, for example, just on the example that I shared with you with the million rows of bananas that I had, and I was making tests to see if it could make predictions that this is in fact a banana. What I did was to scan an application, and then use that application to capture a picture of a banana and run that through the model and identify if the model tells me, yes, this is a banana and this is my confidence level or not. But those are some of the things you could do with your data set once you run it through a model, and the model has been created. You can start making inferences with the model with other types of data sets.
Ladies and gentlemen,
from an improvement perspective, I put a list of items that you might want to consider in terms of improving your project. Here are some examples that I had in here. I always think that the more data you have, the closer you are to an accurate prediction, especially if you chose the right model. So enriching your data pipeline or increasing the size of your data set with more data will be the fastest way. And I'll give an example of what this looks like. Let's think about having so let me think about a situation where we have data sets on how long people stay in traffic in Nigeria generally. Actually, let's just say Lagos. How long do people stay in traffic? If the answer is, and the data set has hours as well, what could you do with that type of data set? You could start helping people predict. And companies like Google are already doing this with Google Maps. You know, you can, or Waze, actually, you could use Waze to predict when it's the best time to leave, because there's a model that works in the back end that helps do those type of predictions. But just imagine if there is like real data that's being captured for traffic, for how long people stay in traffic, and what times are those traffic periods, or what that wait time that wait time the longest. I know you guys are hearing a lot of background from behind. I'm going to pause for this last announcement to be off. Again, I apologize. The announcement is over. But yeah, just think about those type of issues where you have you have a lot of you have that type of data set, and what could you do with that type of data set? You know, the more you have, the more people participate, the closer you will get in terms of, hey, now I know when I need to be leaving my house. Now I know how long it's going to take me if I leave my house at this period. Imagine, just going back to the very first points that I had in there, enriching your data set, your data pipeline with complementing data sources. Imagine that you have a complementing data set, like the amount of migration of people that migrate to Lagos State. So you not only know how much, you not only know how long people stay in traffic, now you know, oh, 500 people have just moved to Lagos. Of this 500 people, 700 bought a car. How can that be like a complementing data source to help you predict how bad the traffic will be in the next 5 months? So that is what I meant by the first point, which is enriching your data pipeline with complementing data sources. So for whatever project that you decide to take, if it's a social project, a health project, a financial project, think of what the complementing data sources will be and how that would enrich your entire data set, and then make your project a little bit more unique. The next point that I would say is review your data set with a different lens. If there's any question that I ask myself so much every day, is I ask myself, why am I doing this? And I try to plug different reasons why, and try to come back to the beginning of what I said initially, which is why. You know, so say you were working on the Lagos State traffic data as an example, and you want to look at that data with a different lens, and you said, how would this differ from the next populous state in Lagos from a traffic perspective? And what are the challenges of the next populous state? Because you've done one project already, it's easy for you to apply the same model and apply the same technique and just kind of do a comparison side by side. The other thing you can do is you can remove variables or add variables, and based on all of that, you're just improving on the very first iteration of what you build. I have the next slide really talks about some of the ideas that I think that even from the second bullet point of increasing the size of your data set or enriching your data set, for every results that you get, I highly recommend, there are some recommendations that I have that I'm going to kind of walk through going forward. Also, I recommend that you tune your hyperparameters with your models. Just tune your parameters, try different algorithms, see which one provides some results, and ask yourself why. Why did it provide this result? The data science field is so much fun, because if you're able to answer that question why, you're really beginning to establish yourself as a thought leader. All right, I know we've got 8 more minutes, so I'm going to wrap this part up real quick. Just a second. Some additional thoughts that I have, and I had a slide here on Vertex AI. I was going to talk a little bit more about that and show you a demo of Vertex AI. I don't think we can do that, but we'll come back to Vertex AI once I'm done with the additional thoughts, which are probably way more important. From an additional thoughts perspective, here are some things that I think you all need to just start thinking about from a broader perspective. Deploy your projects in cloud environments. I know a lot of you probably have like Jupyter notebooks today, and you have collabs, you have all of that, but see what it looks like in the cloud. Build this in in a Google Cloud environment, or build this in any cloud instance, for that matter, and see what that looks like. The reason I say that is cloud is the future. The moment you're doing your projects in the cloud, it makes you more, it makes your resume more accessible and more applicable to an overseas job market. The other thing that I'll point out is, if you haven't heard, a couple months ago, Google Cloud announced Vertex AI, which truly is beyond just an ML engine. It is, in fact, a platform. You could go. I'll recommend that you go read up about it and try to have your own instance or play around with it. There are quick labs that are available that could help you kind of get up to speed. Well, Vertex AI as well is the future. It's a platform that helps you do everything all from one console. All right, the next step, the next thought that I have here is, find opportunities to partner with others. Partner with others, other data scientists in ML projects. I think this is probably one of the most important things that anyone can do to be successful as a professional. You always learn more when you have conversation with others. Before I started talking, I was listening, and I already learned from some of the thoughts and that were presented on this call. And I will say that the more you start rubbing minds with like-minded people, the easier it is for you to just get better at to get better at what you're doing and to get better at your field. Say, for example, we go back to our data set of Lagos traffic, and you spoke with someone else, and that person had a different angle of thinking, and that became a new project for you guys, and you realize that there may be 5 more complementing data sets that you could use to combine it. Say, for example, you're combining the Lagos data set with the New York data set and understanding how does traffic look like in New York, how does traffic look like in Lagos, and how can you project based on population. Just trying to use multiple attributes to just create your model. It creates a window of opportunity for and possibility in terms of what you can accomplish. The next step, the next item on my list is just blog about your ML projects. At every stage of your project, especially once you're done with the data processing phase, the very first time that you create your first model, capture your learnings. Think about what you've learned. Think about why this is unique, and blog about it. I really think that the people who put themselves out there and have an opinion and express their opinion would easily get the fastest learning. So say, for example, I know I had told someone at the last cohort that create a blog and express your opinion and say, hey, I think this is going to be the president. This is this party is going to be the next is going to be the winner of the U.S. presidential election. If you had done that, maybe someone might be reaching out to you right now. If you created a blog and people say, oh, wow, there was someone who predicted based on data, based on these models, and you had all of that well documented, you can start maintaining your blog. Maybe your blog will be generating some ads, or some ad revenue, because people start seeing you as someone who understands data science in one perspective. And the more you spend time doing something, doing it over and over again, the more angles of thinking that you have on that particular subject. So again, I recommend that as part of your ML project, blog about your outcomes and have an opinion. And stand to be corrected, but have an opinion. If your model says something, ask yourself the question why. Relate with your instructors, relate with your peers, and put your opinion out there. People may correct you. People may say that they don't believe what you've written, but the bottom line is you have an opinion, and you're beginning to put yourself out there as a data science visionary. If that makes sense. The last point, this is an area where I would say some of the last cohorts may have been a bit underwhelming. The quality of visualization they presented, I think, could have been a tad bit better. There are many visualization tools. I did everything that I did on here on PowerPoint. You could use PowerPoint as a visualization tool. There are sways, there are Google slides that you could use, which are free. But work on your visualization, because your visualization really makes some people it makes some people light up when they see your work. Just makes their brain light up. There are different types of people in terms of how people learn. Some people learn via words, some people learn via things that they see, and other people just learn by a mixture of ways. But visualization is probably one of the most effective ways. There's a reason why when you watch a commercial say of Kentucky Fried Chicken, KFC, you may feel hungry. Why? Because they polish that visualization. It may not be the real KFC that you will see when you get to the restaurant, but they polish it and make you start feeling hungry already. There's a reason why in America that there are like McDonald's. There's a reason why you see McDonald's ads and the food looks so good, and you're thinking that, hey, when was the last time I went to McDonald's? I'm probably gonna go back there again. There's a reason why those visualizations exist. Why? Because it stimulates the mind. It makes the mind think. It makes the mind reason and wonder. Focus more on your visualization. The visualization shouldn't all be about the beauty. It should also have a meaning. Every visualization that you put out there should have a meaning, because you're appealing to your audience. You're appealing to folks that would eventually be your customers, folks that could eventually be your employers, and folks who you could be working for in other capacities. So work on your visualization and make sure that your visualizations have a meaning, has a story that you're trying to convey. That is the last slide that I have for this presentation. I'm going to take a pause and hear if you all have any questions.
Okay, so thank you very much, Biodun, for this wonderful session. So I'll quickly take the questions. We have a question from Zoom, from Olix. So the question is, my major problem is, how do I learn all these things within a short time? I'm a beginner and I'm being really tasking to know all these terms in data science. Any advice for me?
My advice for you is take the mantra of becoming a lifelong learner. Nothing was learned in a day. I understand that it's a short time, but if you commit, if you write on your wall that I am going to be a lifelong learner, and own it, own being a lifelong learner, it means that you're waking up every day wanting to learn something new. And the more you keep learning, the more you keep getting better. Unfortunately, I didn't have an opportunity to speak more about my own story and my own journey through learning. But I came to the US with a bachelor's. I got 2 masters. I got a PhD. I'm getting an executive leadership MBA from Stanford. I could have stopped at getting a master's, because it's not about the next job. It's more about, I want to learn. I want to know what's on people's mind. I want to understand how people think. Just commit yourself that this is going to be a journey. It's going to be it's going to be a marathon and not a sprint. It's not about the destination of I want to start working. It's more about I want to be a data scientist, and I'm willing to commit all that it takes to get that done.
Okay, so thank you very much. We have another question from Slido, from Edem Gold. Is it possible to become a professional machine learning engineer without a computer science degree? How do you find jobs as machine learning engineers?
The answer to that question is yes. I'm going to give my thoughts from more of a hiring manager perspective. When I'm thinking about people that I want to hire, I'm not only looking for people who have computer science degrees. I'm looking for people who have the right attitude, because technology can be taught. Some of the best minds that I've worked with did not go to school to study computer engineering. In fact, they went to school to study things that were not science related. But guess what? They had the right attitude. They were motivated. They knew that they were dedicated to being lifelong learners, and they learned it, and they are better now. So I would be looking for more of what has this person done to invest in themselves, and how has this person proven that they are continually investing in themselves, and not only learning but also practicing. There are lots of people who have degrees but aren't using their degrees. Why? Multiple reasons. But if you demonstrate that you're learning, but at the same time, you're also practicing and you're continually learning, you're seeking feedback, that is enough to get you to where you need to be. So the answer to the question, you don't need a computer science degree to be a machine learning expert. You don't even need a degree to be a machine learning expert. You could have a degree, and the degree doesn't even have to be a science one. What's most important is your dedication to learning and your dedication to growth.
Okay, so I have another question from Zoom. From David, how can I use AI and ML to solve problems through IoT, Internet of Things?
I had so one of the projects that in my first year in my PhD program, was one of the first projects that I tried to tackle was to capture the data from my home thermostat, which at that time used to be an Ecobee. I downloaded the data for a year-long data, and I tried to make a prediction on what times do I turn on my heater, what times do I turn on my cooler, and what would the next 3 years billing look like based on different variables. You could make anything up. All that matters is finding data. Ecobee data too some customers get to donate their data. Google thermostat data or thermostat data in general are available. But yeah, there are multiple ways that you could use IoT data. And one of the IoTs is just the thermostat. There are multiple other IoTs that are around the house, like your smoke detector or your microwave. They are all IoTs that you could capture data from and use those data to make predictions, or to actually make people's lives better, or to detect anomaly and identify that, wow, Biodo is not typically home around this time, but I noticed that there's an alert that I got on the thermostat that this is an anomaly. What is going on? And you can also respond to those anomalies. You could make anything up. It's more about how imaginative that you are. But yes, there are multiple projects that you can run from an IoT perspective, and those are just a few that I listed.
May I have your attention, please?
So we have another question from Zoom. Do you need math for AI ML? And what statistical tool do I need for analyzing data?
Yeah, so the first question, do you need math? Do you need I'm guessing the question really was more, do you need math knowledge to be a data scientist?
Yes,
that's one of the areas where I would say the answer is a little bit of yes. Computers are making it easier for us, where your AI ML models are easier to interpret than they ever have been. Computers are making it easier, where all you need to know is regression model, and what does regression model mean? And based on what regression model means, you know exactly how you could use it. So you don't need to work it out with your hands, because computers are doing it for you. You still need a bit of learning. You still need to understand the technique. You don't necessarily need to know how to work it out on a piece of paper, because computers have already solved that for us. And I can't remember what the second question was.
Okay, so what statistical tool should he use for analyzing data?
There are multiple tools that I recommend, but if there's anyone that I would highly recommend that you guys go learn, Python would be number one. R is also good, but if you learn Python, a lot of folks use Python today in the data science field. Just learn Python, and there are other tools that have like that can also help, but some of them are expensive. But learn Python.
Okay, so because of time, I'll be taking the last question from YouTube. So the question is, sorry, give me a sec. Sorry. So what is the essence of hyperparameter tuning as mentioned?
Oh, what's the essence of tuning the hyperparameters?
Yes.
Well, when you tune your hyperparameters, one of the things that you're able to do by tuning your hyperparameters is you're able to see what the variability will look like with your model. Say, for example, if you're categorizing, or if your model is looking at specific range of data and you tune those parameters so it's looking at different ranges of data, you can tell there will be some variability in the output, or there might not be. And that just helps you tell the story better as a scientist, that, okay, I changed this and this is what it's become, or I changed this and it didn't make any changes, or I added 17 more lines I added like a couple more rows of data and that didn't change much. The outcome of my model didn't change. It's more about variability and its outcome than anything else.
Okay, so that's the last question for today. I want to thank you, Biodun, for taking your time to, with all the delay and the whole issues that you were able to join us today. I want to also thank everybody for making it here today. And if you have other questions, you can send them via email, or if you are one of our interns, you can drop them on Slack and we'll attend to them. Thank you, everyone. Have a good
Well, thank you very much. I'm going to turn on my camera now. Hopefully it works. But yes, thank you all very much. And I really appreciate you waiting for me to present this. Hopefully the next time we meet, we'll be more structured. I had an impromptu travel, and that's why I'm away. So I'm still at the airport now.
Thank you very much. So for the slide, we'll find a way to get it through to you guys.
Ladies and gentlemen,
all right, thank you, and you all have a wonderful weekend.
Yeah, you too. Thank you.
All right. Bye.
It's now available at baggage claim 5.
You're welcome.
As many bags do look alike, please check